talked about how you assign oxidation numbers. In this video, we're going to talk about how you identify when a substance is oxidized or reduced. So to begin with, I like to use acronyms to help us remember information. One that we're going to use here is LEO-GR. So if you could take out a piece of paper and copy this down, we're going to give you a few examples of oxidation reduction reactions, and you could just bring them to class tomorrow. So LEO-GR stands for loss of electrons is oxidation, and GR stands for gain electrons reduction. Now there are other acronyms that exist, but I think that this one will be most useful for our purposes. So this is the one that we'll go with. You are responsible for knowing the definition of oxidation, which is the loss of electrons, as well as reduction, which is the gain of electrons. So here's a typical redox reaction that you'll see. This represents an oxidation reduction reaction because we're going to see that something is going to be oxidized and simultaneously something will be reduced. The first step in identifying what's oxidized or what is reduced is we have to assign our oxidation numbers. So on the top, let's fill those in. Zinc is a free element all by itself, will be 0. Hydrogen is +1, chlorine -1. Here, chlorine is -1 times 2 is -2. Zinc is +2. And over here, hydrogen is 0. So to identify what's oxidized, well, we just said when you're oxidized, Leo, you lose electrons. We know that electrons are negative. If you lose negative charges, you are going to become positive. So what we're going to do is look at each element's oxidation state on the left-hand side of the equation, and then we're going to look at what it becomes on the right-hand side of the equation. And we have to look for something that's oxidation number is going to go up. Because if you're oxidized or losing electrons, your oxidation number should become more positive. So here, if you see, on the reactant side, zinc is 0. On the product side, zinc is +2. Going from 0 to +2 on a number line is becoming more positive. So zinc solid, in this case it actually would be, but zinc 0 is what is oxidized because it lost electrons or became more positive. So let's look at what's reduced. What's reduced is the one that's oxidation number is going to go down because it's gaining electrons, so it'll become more negative. So if we look at the charges, chlorine stays the same. It's -1 here, -1 here. That's not changing. The hydrogen goes from +1 to 0. So +1 to 0 is decreasing in oxidation number. So hydrogen, and we need to indicate what the charge is, +1 is reduced. When we're identifying what's oxidized and reduced, we're always picking something from the reactant side of the equation. And you're going to indicate the substance that's oxidized or reduced along with the oxidation state that you assigned it in the equation. You're never going to have a whole compound reduced. It's just going to be one element will be oxidized or reduced. So here's another reaction. Again, the first step before we can decide what's going to be oxidized or reduced is we're going to need to assign oxidation numbers. Strontium is up by itself, free element, it's going to be 0. Oxygen is -2, each hydrogen will be +1. Strontium, nice and easy, it's an ion, they give it to us, +2. Oxygen is -1, hydrogen is +1, because it adds up to the charge -1. Hydrogen is a free element all by itself, so it's going to be 0. So to figure out what's oxidized, we need to see what's losing electrons. When you lose electrons, you become more positive. Strontium on the left is 0. Strontium on the right is +2. Since it's becoming more positive, we would say that strontium is the one that's oxidized. Let's identify what's reduced. Okay, so oxygen is -2 here, and it's -2 here. Since it didn't change, it was neither oxidized or reduced. Hydrogen over here is +1. Hydrogen over here is +1, so nothing there. But hydrogen over here is 0. So in that case, the hydrogen was reduced because it went from a number line from 1 to 0. If the oxidation number decreases, you're being reduced. So two things to keep in mind is that when you're oxidized, you lose electrons, and your oxidation number will increase. When you're reduced, your oxidation number will decrease because you're gaining negative charges. You're gaining electrons. Okay, let's go through another example of a redox reaction. Here, oxygen is -2 times 2 is -4, so we have manganese is +4, hydrogen is +1, chlorine is -1, Chlorine is -1 times 2, so manganese here is +2. Chlorine's all by itself, so 0. And here hydrogen would be +1, oxygen -2. So our job is to figure out what's oxidized or losing electrons, which means you're looking for something that's becoming more positive. So we look at what the element is on the left-hand side of the arrow and what its oxidation state is, and we need the oxidation state to become more positive. So let's look at what we have. We see we have manganese goes from +4 to +2. The number is going down, so that wouldn't be oxidation, that would actually be reduction. It's gaining electrons or going down. We see that chlorine goes from -1 over on the reactant side to 0. So on a number line, -1 to 0 is becoming more positive. So oxidized would be chlorine -1. We're also going to add in other words here. Whatever is oxidized is what's responsible for causing the reduction. So we will say whatever is oxidized is our reducing agent. So they could ask you which one is the reducing agent, and you literally would write whatever is oxidized. For reduced, they could ask you which one is the oxidizing agent, and you would literally write whatever is reduced. So you just need to know that these terms agents are flipped, or the opposite. Whatever is oxidized is the reducing agent. Whatever is reduced is the oxidizing agent. And one more thing I just want to mention is that double replacement reactions are not redox. So here's an example of a double replacement reaction. I just want to show you why it's not a redox reaction. I assigned the oxidation numbers for you here. Na goes from +1 to +1. Br is -1, -1. K is +1, +1. Cl is -1, -1. The oxidation numbers here are not changing, so it's not redox. So the conditions we need for something to be a redox reaction is the oxidation numbers have to change. So in all the examples that we did, we had one species oxidized, one species reduced. You cannot have one without the other. They both have to happen at the same time.